We are happy to have Pfaffermayr here. So Michael will tell us today a bit more about the estimations of the universal gravity model. And he has done a lot in international trade actually before. So
Okay, so thanks for having me. Thank you. So I would like to report on a longer-term project I have. And the background is I'm interested in the impact of unilateral determinants on bilateral trade flows. That includes, or that would open, if we know that, how this works, it would open up important avenues to research. For example, it would allow to analyze productivity catch-up among countries, like the rise of, China in recent decades. It would allow analyze industrial policy, like R&D, subsidies, and all this would affect somehow the production or the policy in, say, in the sourcing country, and affects all trade flows originating from that country simultaneously. Okay, and we are estimating gravity models using fixed effects for exporters and importers, and typically that is not identifiable because, this would eaten up by the fixed effects. So what people usually do is they take a trade barrier, a unilateral one. So we have done with Harry and Richard, for example, like the time to export, and multiply by the border dummy IJ, so that this unilateral, this unilateral determinant is transformed to a bilateral one, because domestic trade flows are not affected, but also only those crossing the border. Okay? And the question now is how we can do that. And I came over two approaches to do that. One is by Mario Lach and his co-authors. He has a Journal of Applied Econometrics paper on that one. And what he does is he takes this standard gravity model, that has the bilateral trade barriers. It has the price I minus sigma. The theta is, the value of output normalized by world price. So, I normalize trade flows to 1. And the price index times the expenditures normalized to world trade. And they estimate this, then they know the sigma, they back out this one, okay? Say, by solving the system of multilateral resistances, so they back out this one somehow to get an estimate of this, and then they are able to parameterize this one. Say it depends on capital stocks in their case and productivity possible and things like that, and this goes into a fixed effect of the exporters. Okay, that is what they do. This sounds interesting. The problem is, if you do that, here a head comes in. This is estimated somehow, and they are not able to pin down what this means in econometric terms, how to do inference on this one. So, and I think the referees have been, generous on this issue, and then they went on with this one. Okay, and then I came over this paper, which is a very famous one, and this paper has two parts. One is in writing down a gravity model that is very, very general, based on a few basic assumptions like demand is CS and the iceberg transportation costs and things like that. And they bring back a supply equation explicitly. Okay? So that would mean this one now is a supply equation that they want to estimate. Okay, this is not new. So what I have seen is the early papers of Anderson had a supply equation. Bergstrand had one in these early papers, but Bergstrand assumed that the supply is, decomposable across destinations. So it's a supply curve for each destination, and then you can do that. And they bring the supply equation, and they have a clever approach to identify the supply determinants. And this comes in a two-step framework. Yeah? Okay. So that is the long-term program. I started with this one, and for the first time I thought, well, let's do a replication exercise. So I didn't do that before, but I think one can learn a lot, and I did learn a lot actually. Yeah? So that's the background of all this, and to get this supply equation. And I would now walk you through what they have done, what the supply equation looks like, and I replicate their estimation results they have in the GPE paper. Yeah? Okay, so that's the plan to go. And so we have to, let's see. So as always, there is a effect of presentation up here. Let's see, maybe now, no? Yeah, okay. So what they do is they start out with a standard gravity model that is imposed by them in an axiom, in an assumption, and that says, well, the gravity model is the trade flow from I to J in values depends on, say, trade barriers, the price index, up to minus phi, and phi is a general, demand elasticity that depends on the model you impose. You will see that in a minute. Yeah? But you can think in the standard Krugman model or Anderson von Wincop endowment model. Yeah? And then you have, it's this one, okay. No, I should have done that. Let's see. That is as always the wrong direction. So let's do it like this one again. And so demand is homogeneous in income, and the EJ comes in, and what they typically assume is that the value of output, okay, and the EJ are identical or up to a constant which reflects trade balance, which is exogenous given. I come back to that because it turns out important later. They have the price index, and this one is new up here. That's the supply equation. It has a constant, depending again on the model. They have supply shifters that are I-specific, and the price enters up here, the price index and the phi, and this is the supply elasticity. Okay? Now you might wonder why we have the price index up here, and this is the trick they do, or to make it a little bit more general. They assume that all variants that are imported are also used as intermediates in the same way. Okay? And then the average price of the intermediates is reflected by the price index, because that's the intermediate thing. And they call that roundabout production. Okay? So that might be restrictive, that the relative prices of the intermediates, the price index in the same way is just very elegant up here. Okay? That is why you have this. And we would be interested in estimating determinants of phi and identifying this psi and the demand elasticity. That is what they want to do. Okay? So that is this roundabout production. And what they show is, and this is why this paper is so famous, is that for a wide range of demand and supply elasticity, this model has a unique equilibrium. So the prices are uniquely determined up here. And you know, they have economic geography models in mind with agglomeration and things like that. But what is important up is just here, this one, you know, that's the phi, that's the psi, here is the zero. And in that part, you know, it is unique. What you don't have to have is this one, maybe that's too small. 1 plus phi plus psi is 0, is ruled out. Yeah? Okay, then it wouldn't exist. So that is why it's so famous, this paper. And this is, I think there's Alvarez and Lucas, which is a forerunner of that one, which is quite important because, you know, we solve the system of resistances. We do big models and we don't know whether equilibrium exists or not. So that would mean this is one of the main contributions, which says, well, you can do that. The second part is they show that a lot of models we have are compatible with this approach, because the only difference is that the supply equation is different. And, you know, it is the endowment model comes in, the Krugman model, Eaton-Kortum comes in. For example, in the endowment model, the phi would be sigma minus 1, and the psi would be like this one, and this would be the labor share. You know, we don't have a labor in the Eaton-Kortum model, but you might do that. The problem is, it would be interesting without, say, roundabout production, but this is not covered up here. So you have to write it from scratch because, you know, if this is 0, that is not really defined, okay? And the Mellitz model comes in as well, having even more complicated demand elasticity, and the theta and theta up here just capture either heterogeneity in the Eaton-Kortum's model, or they capture say the Pareto parameter possibly, okay? So in short, this is quite general and covers several specific approaches. That is what they claimed up here. So I do that for you, and it depends in the end how you interpret the parameters. What you think about what the which model the trade flows generated in the end. Okay, good. So that is the first part, and then they had a second part in the paper. And then they wanted to estimate the demand and the supply elasticity, okay? And they had a really clever way to do that. And that means they first said, well, let's look at the relative model, xij over xjj, okay? Then you see that is for each destination j, you get the income eliminated, and also the price index is eliminated. Okay, so the resistance terms with respect to the importers, the inward resistance term is eliminated. And what is left is the relative trade costs up here and the relative prices up here. Okay, and they went for logs. I will tell you later on why they went for logs. They had good reasons for that. And they parameterized the Tij by some explanatory variable Zij. Okay? Here you see that's like distance, like, you know, common language and all that. And if you see this one and that one, that turns out to be, say, the fixed effects up here, fixed export effects, fixed import effects, and these capture the prices up here. Okay? So what they observed is, well, actually, this is a fixed export effect that comes on the exporter side as a PJ, so it is somehow restricting the import of fixed effects. Huh? Okay, so and then the added disturbances up here. Okay, and in the end, what they said is TJJ is 1. We can't identify that. We can't handle epsilon JJ, which is the trade shock, the domestic one. That would come for all exports to J. It would something like a random effect, yeah? And it would lead to equicorrelation. Okay, equicorrelation is the variance-covariance matrix of a random effects model, where the correlation between any say observation pair in a group has the same correlation. Yeah? Therefore, it's equi. Okay, and they have this restriction up here that the PJ is the same as the PI, but turning up at the position of the exporting country as an importer. Okay, so that is what they do, and you see that's estimated easily. Yeah? You just have to do a dummy design matrix for these two guys, and then you estimate, say, OLS or fixed effects, whatever you want. Yeah? Okay, so it is this one. And then they had a second clever trick when it comes to the supply function, because they said, in terms of observables, what I can do is I can take the value of output divided by the volume of output. That's the definition of the price. Huh? Okay, so doing this one, they plug in and they get the yi up to phi. Okay, because it's pi up to phi what they have to parameterize, and then you see the supply curve comes in the denominator, so there's minus phi and so on. So this comes in, and then as a second step, they said, well, let's check about this term up here. Yeah? So that's observable. This has determinants. This is not observable easily. However, you can check out the share of domestic trade in output, in the value of output. Okay, and if you do that, yeah, you have to check the trade balance times the output. This is this lambda II, the share of domestic sales in total sales, if you want to, and total expenditure, yeah, as it should be. Okay, and then you see if you plug in for that one, yeah, going back to sorry, that doesn't go back. Okay, so if you go back, you see it is exactly what we need up here. Sorry for that one. I have to go back and shouldn't use this. Button up here. So, if you go back up here, you see, if you look at this one, if you put that to the left-hand side and you look at the ISJ, you see that one is left. Okay? So the share of domestic trade is actually defined by the price divided over the price index, and then you have this phi in it, yeah? And TIJJ is 0. Huh? Okay, so that is what we have up here. Okay, and that is clever in the sense because if you bring back that up here, yeah, you get a supply curve. On the left-hand side is this one, which is parameterized as pi, which is the estimated fixed effect in the end. Okay, then it depends on the y, that's the value of output, and the parameter is the elasticity of demand, which would be identified if it is good. Okay, then you have the second term up here. That's the lambda II, okay? And remember, this is multiplied by phi, so it's the psi is left. And then you have the, the demand shifters, okay? I skipped the constants. There's something left in terms of constants, but that's not important. So what they did is they parameterized the supply curve, having the PI on the left-hand side. On the right-hand side, you have the YI, the lambda I, and the demand shifters, and a supply shock omega I. Okay? And this is clever up here because, but you will immediately see, well, that's output and that's domestic trade share. That's of course endogenous. Yeah? So you have to think what to do about that later on. Okay? But this is the clever solution how to do that. And that would mean, in the end, you will do a two-step estimation. Yeah? Okay? And what I did next is I went to my favorite econometrics book I learned in the 20 years ago and looked up what you do with supply and demand systems. Okay? And I always teach that in econometrics as well. And they write, before you go on, you should look what is the reduced form. Because if you learn the reduced form, okay, then you know what the instruments would be. And that would mean, in the end, you plug in the supply and the demand curve and solve this. And on the right-hand side, only the exogenous shifters come in. Okay? And I wanted to do that here, and it turned out that's impossible. So there is no reduced form. And to see this, what I did is I translated the model to the econometric specification. And if you do that for the gravity model, you have here the nominator, which is capturing actually trade costs and things like that. This captures the price index, which is the sum, okay? And remember this one parameter is PI up to phi. So it's like that one, and then you have income up here. Okay, and then, the supply curve comes in, that's this one, and it is then up this one because it's the value of Y, yeah, and not Q, okay? This would then be the supply curve. That would come from the roundabout production, and the nominator comes because world trade flows are sum up to 1. Okay, so you get all in shares. Huh? Okay, and the lambda I is also easy. It's like this one, the PI and the PK. It's just like this one. Huh? Okay. So that's easy. I write on the left-hand side up here that the PI depends on the pi, the omega, the epsilon, the theta, because in the end, if I look at the green book, the supply and demand shocks are in the model. Yeah? Okay, that is different to the treatment we see in the literature. Yeah? Okay. So if you believe me that it's like this one, and there's no need to go over that in detail, you then go on and say, well, you might solve this model by saying output up here in country I adds up all trade flows that come from the other countries. You can do that in J and I as well. I did it like this one. And you have to check that this one is actually that value of output from the last slide. And, that is a highly nonlinear system. Okay? And now the question is, if you solve this system, what is about the stochastics in that model? Huh? And I leave it to you, and then you see the epsilon, the demand shocks come in here, they come in here, they come in here, and the omega comes in here. So in the end, what you get is, you get a solution PI, you solve in P, that is correlated in many dimensions. I cannot work out how this looks exactly, but that's clear that this PI is not independent. So, and it depends on the demand and supply shocks. Okay? So it is like that one. Okay. So having learned that one is, you know, you can check what the literature makes, and what they usually do is they ignore the epsilons and solve at expected value in a non-stochastic system. That is what you can do. In the end, you don't observe the omegas or so on. Yeah? So, yeah. For example, if you observe the kite model, it's more general, but in the end, they don't have the epsilons and omegas in it. Yeah? Okay, so it is like that one. To go on, what I do is I select all parameters in a theta. I assume the fixed effects solve the system of multilateral assistances, what we have seen before. Okay, it turns out that 1 pi has to be set to 0 because it's a more rare. It's also interesting for the replication. We have to be in mind that because of the normalizations, we don't have any levels. Yeah? We neither have the level of the quantities nor the prices. It's all relative. Yeah? Okay. But in the end, that's not really a big problem. Okay. We went go on next and said, well, the first demand equation is easily estimated. Let's concentrate on the supply equation. Okay. And they devote quite a lot of space in their paper on how to construct the instruments. Okay. And, you know, if you have the reduced form, you would go to the reduced form and then calculate the endogenous variables depending on the determinants, hoping that your system is you know, demand and supply is identified, but that depends on the shifters, whether you have demand and supply shifters or only one of them. And they do the same, okay? They go on and, you know, they check the non-stochastic equilibrium. They calculate the p-bar. Under the assumptions, they had observed the trade friction parameters beta. So that means they can, they know the demand curve. They have the betas. It is a head, but that is ignored. And they solve the system for epsilon and omega is 0, okay? Then they have these p-bars, and then they go on, this is the instrument, okay? And what they call it G instrument, general equilibrium instrument. And then in the next step, they say, well, let's do IV estimation. But you know, IV estimation is linear in the first and the second stage. So that in the sense they propose, there exists something like a linear reduced form, okay, that can be used for, say, IV estimation, and to propose to use the LNI bar and the lambda I bar as instruments that derived by solving the system without any disturbances, and under the trade balance assumption. We have this all works in MATLAB, and they have a procedure that's called balancing, and before they solve the balanced trade flows. Yeah? Okay. And so they postulate the linear function. I checked around for quite a long time, and maybe a clever, say, econometrician can produce a linear approximation out of this that produces this. Yeah, okay. And they assume, in the end, for inference, that this linear reduced form is correctly specified, and that the omegas are independent across observations or across continents. Actually, the latter one. So the cluster. This we will talk about that as well. So the omegas, the supply shocks, might be correlated in their case because they cluster by 6 continents. Okay, so it is like this one. And you might have observed that this model is just identified. You have 2 instruments for 2 endogenous variables, which is a comfortable situation because there's no Sagan test you can do or things like that. Yeah? Okay. And it turns out this is a major weakness, yeah, because these two instruments are quite correlated. Yeah? A big country, why I might have a big share of domestic production. Yeah? Okay. And if that's the case, and they are perfectly correlated, then you would not identify the model. And if they are weakly correlated, but not that much, the instrument turns out to be. Okay. Further, one has to say, that's also in the paper, that this only works, these instruments, if trade barriers are non-symmetric. Okay. So once you put in distance, common language, and things like that, that is not enough, you wouldn't identify this. Huh? Okay. Again, you have to go over some pages of proof to see that, but in the end, it is like that one. Okay. So my idea now is I want to have a third instrument. I want to have an over-identified model. I want to have a third instrument. And currently, I have one idea. And the idea is, to use the trade balance as an instrument. Because, if the trade balance comes in, output and expenditures are different, and therefore is output and lambda I, yeah, the domestic trade share. Okay. Now, you learn about instruments, and then 3 points you have to know. It must be excluded, it must be exogenous, it must be adequate so that it works. And you can say it's excluded in the sense that it does not affect, the demand equation only via the pi's. Yeah? Okay, the pi's depend on the trade balance. It does not enter the supply equation directly, only the yi and p lambda I are affected, which is what I want to have. Okay? Now, from a theory point of view, they are exogenous, this pi. Okay? And in the end, it turns out it must not depend on the omegas, which is a big assumption, because it says if you have a shock in yi, expenditures increase by the same extent. Okay, then the trade balance would be unchanged. Huh? Okay, it would be not affected. Thinking on Greece, for example, I know that's not the case, but in the end, this is what they do. Yeah? So you have to have an exogenous y, and they should then be explaining lambda y and lambda jj, and if we all buy that, then we have an instrument. Yeah? Okay. I have to say the first two cannot. This one cannot be tested, but it's plausible and based on the model we have. This can exogenate. It can check using this Sagan test or something like that. But in the end, econometricians believe you can't test it. Yeah. And this one will turn out, yeah? Okay, so that is what they do. And then, they come up and say, well, the estimation procedure is simple. You estimate the first equation, demand. It is written down in vector form like this one. The left-hand side is this log ratio, okay? And then you get the pi's, and the pi's then depend on the supply shifters and the lambda and this one, okay? That is the easy way to go. There are two, things to note. The first one is, if you have domestic trade flows, this cancels out. So domestic trade flows enter up here. And that would mean you estimate the pi's without having domestic trade flows, which might be a drawback, okay? And the second remark is this pi comes out of a fixed effect. This is coming here, and the D is the sign matrix that produces for each observation a pi minus pj. Okay? That is what you do. You just have a 1 for at rho I, then you look for the importer that is below down, and that gets a -1 as well, and then you have it.
So does it have n or n?
And you can do that, and you project out these guys like a fixed effects estimator. That's easy, yeah. And then you have the betas, yeah.
Just one question about the D. Does it have n or n-1 columns now? Because before you had the
that is n-1 times, yeah. Say for econometrics later on, it is better to have C, but in the end you need C team n-1. The problem with the Kolakis paper is that they don't exclude the numeraire. So the numeraire comes in, but Stata corrects them and skips them. Yeah? Okay, so it is like that one. Okay, so that would mean you easily get something like a fixed effect estimate. You just have to project out this. What you do is you estimate this model in OLS using the dummies, the dummy design. Okay, so that could be easily done. Okay, and then they do the second step regression. The left-hand side is p hat, and this p hat depends on the estimated betas, as you see here. And it turns out it is like this one. Let's first look at the left-hand side. And if you look at the literature, you find out, well, that's well established. We know how to estimate these fixed effects depending on another variable, because there's a very well-known interesting paper by Pesheron and Su, which makes that. And he says you have to do the residuals from the first stage, take x minus z beta hat, call it u hat. This is then what is left up here, okay? That is, and take the mean, which is d prime u. If you have just, one fixed effects as Pesheron has, no restriction on that, it's the pi. You take the mean, and this makes the sum, and this makes the mean. D prime D inverse is just by dividing 1 over t, yeah? Okay? And if you look at the algebra, you see in the end that this u hat is exactly actually the p hat that we do. Okay, you can check the first order conditions, then you find out. And what they produce is difference between group means. That is what they do. Okay, not that important. Important is this is p hat. And then you see it depends on the true parameter, the omega, that's the x, the epsilon, and here the estimated parameter comes in. So if I would know the beta 0, this would go up, okay? And if it is to be estimated, that is what comes in, and the epsilon comes in, okay? And it turns out, well, if you do the regression on the V, which is the demand shifters up here, then you would get an estimate delta, then that ignores this. This is what Pesheron and Su say, yeah?
Just one question about the epsilon. I thought this was IJ index before.
This one?
Yeah.
That's the whole vector epsilon.
But the U is only I indexed. Or...
Yeah, I see. It's a little bit, say in the notation, a little bit difficult. Let's see it like that one. This one is the full vector, okay?
Stacked.
Stacked, yeah.
So
okay. And D prime makes the mean out of this. And then you get, of course, the mean out of this and this one as well. You see it in a minute, yeah?
Okay.
Okay. So in the end, what you do is this one, and then you see you have to D prime D, this one times epsilon. That makes, in the end, epsilon bar, yeah? So the mean. And it makes this one as well, okay? And, well, that would mean we have that. You can take out two conclusions. The next step would be, before going to the two conclusions, the next one would be you estimate this by just doing IV estimation. Yeah? Okay, and IV estimation means you regress the supply side variables, the V, that include the endogenous ones, on the instruments, okay? Take the predictions and then do OLS. This is what IV does. And therefore you see this pH comes in. That makes the predictions of V when you regress on the instruments. And that's all fine, but what you see is you get a complicated, disturbance system. So that comes, and that comes because you estimate the beta. Okay? Now, as I said, two conclusions. The first one is you might stop here and say, well, I write a procedure that estimates the demand, the supply, the pi, put it in one and do a bootstrap. Okay? Or you check what the variance covariance matrix of this guy is. Yeah? Okay? And this is what Pesher and Su makes. Can be done. The paper has an appendix that is as long as the paper itself, and he establishes how this looks like. So I don't give you, much information on that one. He says, you can show that these supply parameters are asymptotically normal, like this one here, and the variance covariance matrix is augmented by this one. If you take that one, that's the usual IV estimator. That's not interesting. So this guy comes in and you can estimate that. Okay? I think more is not necessary. Okay? And the only thing is this omega up here, is it important up here? Yeah, okay. And this omega depends on the variance of beta hat. That is written out here. And it turns out, I've learned that, it depends on the setting you have. Maybe we go on and then go to the empirics. And this is quite tricky. In the end, you estimate the beta and you use n squared observations for that. Okay? You have this trait matrix, you use n squared observations. Okay? And then you go to the supply equations and you use n observations. Okay? And you estimate the pi using n observations because you have export effect, and for each exporter you have n importers. Okay? And now the gravity model is symmetric, quadratic. So you have, if the number of countries increases, the number of observations to estimate the pi increases as well. And that would mean you can estimate it precisely and the beta doesn't work, does not matter. Okay, that's good news. So you can go on and ignore this. Yeah? However, this is only the case if the supply shocks are independent and if the demand shocks are independent. Yeah? If the demand shocks are clustered by importer country, for example, if you cluster that, you assume that for each importer, all exporters are correlated, and in the end, it looks like having just one observation. And if that's the case, then you can't ignore that. Okay? So if you believe that that is clustered, then you have to do this correction. Okay? And, clustering is possibly an idea because this epsilon JJ comes in, the trade, the demand shock of the domestic trade. Okay, good. So that's the background. So my contribution has a few pages on sorting this out. It adapts this special soup paper to the case of P infinity, to a large T, n large T panel. Pesheron is n and T small. And this is a large and large T, okay? Good. As you will see, this is in the end saying I could have say ignore that, okay, but I did it. So what they then do is they take the model to the paper, use GDAP data, okay, and they have 94 observations, okay, and the explanatory variables are rather fancy in the trade model because they want to make it as asymmetric as possible. And what they do is they put 11 distance classes interacted by the continent dummy with the exporter and the importer, makes 396 dummies in this model up here. And the problem is, if you do that in Stata, you get a mess because many of these cells are empty. Okay, so 209 cells are non-empty out of this. Okay, they have also 6 cells distance class 0, which is also interesting because in the end, they run these models, including domestic trade, having a 0. Log of 1 is 0. Okay, so for domestic trade, 0 is in the trade data on the left-hand side. But it turns out they had good luck because these dummies explain them perfectly. All of those having domestic trade are in the class 0, having the biggest distance. The lowest distance. Okay, so that is what they have. And then they have a few cells that are dropped because of collinearity. I still have to sort out what actually happens up here. Okay, so it is like that one. And then they have the p-hat estimated by OLS, have the p-hat, and then they go on and say, well, let's look for explanatory variables. And they use, well, area, desert, tropical dummies, interactions of that, no cost, near cost, population at 14, European descent, rule of law, R&D, and schooling, and a really fancy, say, demand thing is because they lack a lot of data for schooling and R&D, they put in a dummy for those who are lacking. Okay? So, yeah, but in the end, nobody cared about this, possibly. But yeah, that is what they do. Okay, and this is what they get. Okay, so the estimate here. This is their preferred specification, table 2, biggest set of explanatory variables, and they find out the demand equation is 3.72. It comes as an absolute value. Yeah, you should take that negative. And what is interesting, the supply equation is 61.49. Okay, and they estimate. I could replicate that. Okay. And the standard errors are clustered by continent, okay? I have to say one word how you get these estimators. So the point is, to get the instruments, you must have estimates beta hat. So what they do is they do OLS, then they have a stop, then the line comes, please run a MATLAB code that produces the instruments. And that goes back, is matched to Stata, and then it goes again. That is how it works. For every beta, you get new instruments. Okay? So I did it like that one. And then I thought, well, for clustering, what you need is small clusters and very many of them. Okay? So the asymptotics for clusters is cluster number of clusters goes to infinity and cluster size is fixed or not growing not too fast. Okay, and this is crazy. You have 6 clusters having on average 15 observations. So, and I then thought, well, let's do say this in as a robust. And what you see is here I get say a smaller variance, and here I get a bigger one. Yeah? Okay. This does just affects the standard errors. Yeah. And then I did this two-step procedure, and it turned out it's more or less the same. And I thought, well, that means my replication is not useful to anybody because, who is interested in doing two-step. But the reason why it's the case is quite interesting. Yeah? Okay. So I take that one, and then I thought, well, this is a little bit fancy because it predicts a big negative value of the pi for the numeraire. So what I did is I left out the numeraire, and this is that one. And what you see is the demand equation, side elasticity is now bigger, and this is now this is more or less the same. So it is not that much. Huh? And one and two step is the same. Huh? Okay. So and going back to the say to the models they imply, we know that this one is the psi, and this should be the theta 1 over theta, the labor share in the model. So the share of in the Douglas of costs that go to labor, and the other goes to intermediates. Yeah, okay. And it turns out this share having this one is 98.6. So it's crazy. Huh? Okay. Clearly, so if you do the inverse of that, it's the case. Huh? Okay. Then I'm nearly done. I checked the first stage. Don't want to say too much about that. It turns out, if you look at the second equation for the lambda, you see one instrument is weak. Huh? Okay. And then I did the same. Let's do this one. Having the third instrument, you see it is more precise. This is smaller. So the Hansen test of over-identification doesn't reject, and we get a labor share which is a little bit smaller. Overall, it's not really plausible. But I would say, that this one is preferable. I would go for that one. Okay. Then I plotted what it makes, and then you see this is the residuals of the demand side gravity model in logs, which is fine. Mm-hmm. If you convert it to levels, yeah, with some assumptions, you see that doesn't work at all. Yeah? Okay, so the big ones are heavily over-predicted. Yeah? So you see this log thing is really difficult, doesn't work well. I then checked, I want to have pi's which solve the system of resistances. Yeah? They are equilibrium prices. Yeah? It's estimated fixed effects, but there's no guarantee that this solves the equilibrium prices. So I checked this, and it turns out you can check this by just checking whether the xij's add up or not, and they don't. Okay, so this is deviations in the predicted output share, and you see it's quite big. Okay, so that might be a problem, that you don't get prices from the fixed effects that solve the model. Yeah. Okay, and then I checked the residuals and the fit of the say supply curve. Here you see the predicted and observed L and Y, the first endogenous variables, and the predicted one from the first stage. You see that works quite well as an instrument. Then you see the lambdas. Again, not that bad, but not that good. And here you see that they are correlated. Huh? But this was really surprising. And you see what to do with the regression that actually has no predictive power at all. It turns out from the supply equations, only 3 variables had been somehow significant, all others not. Okay, and there is not a single variable that makes really a strong prediction. And you see, you would have it like this one, but now it's like that one. Okay, so the big ones, underpredicted, the slow ones overpredicted. There's no power whatsoever. Okay, and this is the reason why my two-stage procedure doesn't work, because the mean square error of the second stage is a factor 10 bigger than in the first stage. So that would mean if that's the case, it doesn't pay off. However, if you have a stronger model, then possibly it works out. So what remains for me to do is, currently I'm looking at a better set of explanatory variables. What can I use instead? And the next step is the question, can we do that with PPML? And here, one problem comes out, that is my finishing conclusions up there. If you look at the residuals, how to estimate the variance covariance matrix, what you need is this one. You need the residuals of the gravity model minus the systematic part of the supply curve. So you need that one, okay? And the problem is now this comes in the exp, and the error term comes multiplicatively. So if you manage to get this from a Poisson model, then you can do PPML as well. If you don't have that, then it doesn't work. Okay, so you see, going over that, a lot of strange things come in, but I think there's a lot to learn. And to finish, I think once we could manage to estimate the supply curve, we would make a big step, because there are so many issues that are unilateral. Yeah, that is done in one country and affects all shipments to all destinations, including the domestic ones. Okay, good. So thanks for your attention. I stop here.